what we're going to do is a follow-on to what we did last class. But instead of addition subtraction, we're now going to do multiplication division. I am going to give a quick shout out. I apologize, B3 class. I didn't pull the mic out, so it's not you on the recording today. It's actually B4. What we're going to do, and we're going to walk through this step by step, kind of like we did last time. We're going to look at how do I do it through models. Then we're going to walk through it algebraically before I set you loose at the end and let you actually get some of this in practice. The steps are going to be pretty much the same as what we did last class. We'll rewrite those in a little bit. But let's look at our models first. So if I've got an equation such as 3x equals 12, a way to think about this, think about the x as being the amount that is hidden inside each of our 3 coffee cups. So I've got 12 marbles, I've got 3 coffee cups, and I want to know if I divide them up evenly, how much is going to be hidden in all 3 so that it's equal to 12. So how many marbles are in each of the coffee cups? Well, one way I could think of it is, well, if I start taking marbles and putting one into each cup, I can see that what I've done with the way I have my marbles set up is basically each row is going into 1 cup, right? Meaning that each of my cups would have how many marbles? 4. So inside each cup would be 4 marbles, or my x equals 4. Does that make sense? Why not, Tiger?
That makes sense, but like I looked away and started chapter.
Yeah, I was like,
You gotta pay attention.
I like wrote my name and I looked up and I see that.
Okay, so what happened, Kyla, was we were putting 1 marble into each cup, and we discovered that as I did one set, that was basically putting each row into a cup.
I know the answer as soon as I looked at the question.
Good, but do you understand why? Here's our big one. So now I'm going to give you guys a chance using that example. Work with a partner. I want you to solve each equation using a multiplication to represent your variable and colored counters. We don't have color counters, so you're going to draw little circles. So you're going to use boxes of x's and circles for your numerical values and figure out how could I set that up to make each of those work. So I'm going to give you guys about 5 minutes to work on those 3 problems. You may work together as a table if you would like. We only have so much time. So yes, we're going. Our first one, basically, again, for each box, I have an x. So on this side, I had 4 boxes. That was kind of nasty, actually. On the other side, I have 8 counters. So to distribute them, 1 would go into each. Then I would start over, and then I see a second one goes into each. Meaning, I know it's beautiful, isn't it? Meaning, so each one, I ended up with 2. So my x equals 2.
does it matter how you draw them out on the side? Because I did 4 rows of 2.
That's fine.
Okay. It
No.
made my lines neater.
Yep. It would have. Our next one, and this one I'll do a little bit neater. So I've got 3 boxes of x. I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So on this one, I can actually see that if I just go straight across, I had 3 boxes and 3 rows. Each row had 3. Make sense? Our next one, now I have 7 x's. So I have a lot of boxes to draw. 4, 5, 6, 7. 7 boxes of x. And I have 14, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the same as what we've seen before. As I go through, guys, please stop the chatter. I have 1 going in each of the box. That 1 row just exactly filled an entire set of boxes. So that means that's going to be 1 set of boxes. That'll be the other set of boxes. So my x equals 2. Does that make sense to you guys?
I got 7.
Okay. Now, the reason we took those steps is for our concrete learners, those of you who need to actually be able to visualize what's happening. I will be honest, I would never again do this. That's a lot of work. But if you're someone that needs that, you actually have another tool in your toolbox now to be able to solve these kinds of problems. Instead, let's turn the page. We talk a little bit, that's more of a multiplication piece. We can also do this visually using division. So I'm not going to make you guys do this one alone yet. We'll just go do this one together. So I've got 3 teachers who went to a conference. They shared the cost of gasoline, G, equally. Each teacher paid $38.50. So I'm going to do a bar diagram to find the total cost of our gasoline. So in other words, this bar, this entire thing, is that quantity G, the total cost of the gas.
Right in the box.
What did each teacher pay? Gabby?
$38.50.
$38.50. So each teacher, their piece of that total gas price was $38.50. But they shared it equally, right?
Yes.
So how many of those pieces do I have? 3. So I have 3 pieces of the $38.50 that makes up what my total gas cost was. So if I wanted to find the total gas cost, what could I do? By 3. So I take the $38.50 and I multiply by 3. I get 0, 15, remember I had 2 decimal places, 24, 25, 9, 10, 11. Put my 2 decimal places back in. They spent $115.50. Okay? So the total, that's actually pretty cheap for a trip. My wife is the president of the Overseas Nursing, School Nurses Association. So she had a conference in Denver this year. We were in Arizona, so we had to drive all the way up to Denver. Had to do an overnight, so we actually spent probably close to $1,000 on it.
Wow.
So getting by for $38.50 was pretty cheap. But the total price of gas was $115.50. Now we could also do this using a number line. So basically the first teacher, the 0 teacher, didn't have to pay anything, right? Because there's no teachers. My first teacher, now the cost of the gas was up to $38.50. My second teacher, I added that same amount, so now I'm at $77. By the third teacher, I add that $38.50 again, so now I'm back to $115.50. So my number line, I could go use a number line and get to the same amount. So that's the number of teachers, and that's the dollars for gas. Does this make sense so far?
Yeah.
What's wrong? That's just this is this. It's just on a number line format instead of using a bar diagram. But it's the same information, just 2 different ways. So whichever way you feel better on, you'll be able to do. Our next one, Sylvia has completed 8 math exercises E. This is 1/4 of the assignment. How many exercises were assigned? There's our question. So much as we just did. So I've got a total number of exercises, E. And each 4th of it is how many exercises? 8. So there's 8 for the first 4th. The second 4th would be 8. The third 4th would be 24. The third 4th would get us to 32. So I could do 4 times 8, because to get all of the exercises, I would need to multiply them all together. So the other way we can look at this is started at 0, 0. So our number of exercises for each portion of the assignment would have been 8 for the first 4th, 16 at the second fourth, 24 at the third fourth, and 32 once we had completed them. So our answer would be there were 32 problems or exercises. Make sense? Okay. Give you a second, make sure everyone's got that one written down. Our next part here should be really, really familiar because this looks exactly like we did last class. So we're going to do the scale piece again, but we're going to look at it. If a scale is a balance, that means it has equal amounts on both sides, right? Does everybody agree with that? Yeah. If my scale is balanced. So we can think of the center of our scale as being our equal sign. That's the exact same notes you guys had last class. So that part isn't changing. We're also going to draw a dotted line through the center of our scale to keep the two sides separated. Okay? Now on the scale, we're going to change our problem up. I'm going to do 2x is 6. So I have 2 x's on this side of my scale. On this side of my scale, I've got 6. So that would mean each x equals what?
3.
Does everybody see that?
Yeah.
That x is 3, that x is 3, so x equals 3. Now I know we have at least one person that wasn't here, so I'm going to redo this. So I want everybody to go ahead and write this again. You should have some extra space up in kind of this area of your paper. And we're going to just write down our 5 steps really quickly again for solving our equations. Okay? Our first step, very simple. Circle the variable. Our second step is to draw the line through the equal sign. It's an equal sign, not a smiley face. Our step 3 is the one that's a little bit long, but this is really one of the most critical steps. Find the number that is with our variable. It's supposed to be a capital W. I'm having issues with the board today. Oh, that one erased decently. Let's try it again. So, find the number with the variable.
Do we need to write this if we're all
Yep. Do the opposite. Operation with that number. So today, since we're doing multiplication and division, those are inverse operations. So if it is multiplying, I'm going to instead divide. If it's division, I'm going to multiply with that number. Step 4, do the same thing on the other side. And finally, step 5, and this is only if we're dealing with fractions really, is simplify. But remember, we always do our fractions in simplest form. Okay? So with the variable, find the number with the variable, and then that says do the opposite operation with that number. Okay. So what does that look like algebraically then? I'm going to take my equation, 2x equals 6, and we're going to go through our steps. Step 1, circle my variable. Step 2, draw a line through the equal sign. What number is with my variable? Ethan? not a hard question. 2, what's the operation when I write them side by side? Zalami? Awesome. So the opposite of multiplying would be divide. I divide both sides by 2. Now I have 2 divided by 2. Those cross out. Now I just have 1 times x. What's 6 divided by 2? 3. Uh-oh. I still have a problem. I don't have x by itself yet, do I?
Can we do it again?
Okay. No. Now we actually go to another property of mathematics. So there should be room down at the bottom. We're not going to use all that scale. I want you guys to add an additional property. Who remembers the property we always strove for last class? What were we trying to do with all those problems? Zalami? Kyla?
Additive identity property.
Of? Good. Additive identity property of 0, because we were doing adding and subtracting. We were always trying to get our variable plus 0, because we knew that that meant we had 0, or just our variable on that side, right? Because anytime I add a number to 0, it's just that number. Today we're multiplying. So additive property of 0 doesn't really help us. Instead, we're going to use multiplicative identity, because it is an identity property. What number did we just get to? 1.
Oh yeah.
So given the additive identity property definition, anybody think you can guess what the multiplicative identity property of 1 states?
Yes.
Gabby? Says it right in the property.
Identity. You multiply 1. Oh, anything times 1 is the same thing as the other.
That number.
Yeah.
So any number, you are. Once you actually start doing your work.
I do.
Oh,
Now
I have
I
a.
do. Now I do.
Any number times 1 equals itself. So why is that important? Because I've gotten to a point in my problem where I have 1 times some number that equals 3. But because of the multiplicative identity property of 1, I know 1 times x is just what? X. So x equals 3. I now have my solution. Go ahead, Tiger. You have to give permission. Sure. Don't. Okay, now the next one. We're going to use our scale again, but we're going to do 1/2 of x is 6. So in other words, on my x side, I actually only have half of it. So I'm only looking at half of the x, and it's going to equal 6. So if I wanted the whole x, what do you guys think I should do? Cry? I don't think you have to cry, Swami. By what? Why would I multiply by 6? Half of my x, this part of my x, is 6. So how much do you think is in the other part? The other half. So if 1/2 is 6 of it, the other half would only have 3 in it? Ethan? So if half of it has 6, the other half would only have 1. Oh, so if half of it has 6, the other half there's nothing there? No, there's something there. Zalami? Why 6?
Because it's the other half.
The other half, right? What do you know about half? The other half is exactly the same, right?
Yeah.
So the other half would also have 6, meaning my whole x would have how much? No, half of my x was 6. There's half of my x. Here's my whole x. So my whole x is, does that make sense? Are you sure? Because you guys struggled a little on that one. Makes me worry.
A little bit.
Okay? So, there's not a ton of room, but what is the same and what is different between these examples? So what was the same, Ethan? They both have a value of x on one side and a number on the other, right? What was different? This one I had multiples of x. This one I had parts of x that I was trying to find. Make sense? So let's look at this one really quickly. How would I solve this algebraically? So we've got enough room here. So again, I'm going to rewrite it just so we can do our piece. Step 1, circle my variable. Step 2, draw a line through the equal sign. What number is with my variable? 1/2. 1/2. What's the operation? We're going to write them side by side. Times, right? What's the opposite of multiplying? Division. So how do I divide fractions? Because I'm now saying I need to divide by 1/2. Remember, Gabby? How? How do I divide fractions? In other words, 1/2 divided by 1/2. Joaquin? Keep, change, flip.
Oh, yeah.
I don't actually divide fractions, right? That math is really conceptually difficult. So instead, I actually multiply by the inverse. Because mathematically, it makes more sense. So instead, I multiply by the inverse. What's the inverse of 1/2? 2/1. Anything I do to one side of my equation, I must do to the other side. Correct? Multiplicative property of equality. If I do anything to one side of my equation, I must do it on the other. So what's happened now? I have 2 on top and bottom. That's just 1. So now I have 1 times x. Multiplicative identity property of 1. I know 1 times x is x, because any number times itself is that number. On my other side, 6, I now have a fraction. I need to put it over 1. Nothing to reduce by. 6 times 2 is 12. 1 times 1 is 1. I was trying to say the answer instead of the 6 times 2. 12 times 1 I know is 12. So that algebraically is how we solve what we did in the model. Yes, Swami. Oh, thank you, Zoami. I really appreciate you right now. What? What? Okay, Zoami. So you didn't understand I circled the variable. You said you didn't understand any of it, so let's go through it. Zoami, you didn't understand how to draw a line. Drawing the line's really hard? Oh, you got that. Zoami, you didn't understand when I put numbers beside each other that I'm multiplying? You don't understand that? Oh, well, you said you didn't understand anything, so hold on. So you didn't understand the opposite of multiplying is dividing. Oh, you did understand that. You missed the whole key change flip, that I don't actually divide fractions, I multiply by the inverse. Okay. So, Ami, to divide fractions, you multiply by the inverse.
Yeah, I know that you flip it, but like when you crossed out the 2.
Okay. What is 2 divided by 2? So that's our reduction. I said I have a factor of 2 on top and bottom. 2 divided by 2 is 1. 2 divided by 2 is 1. I just made them 1s to make the math easier. Because guys, please stop. When I did the math, I multiplied by 2 here, correct? The multiplication property of equality says, that's okay, I can do anything to one side of my equation. As long as I do the same thing to the other side, it will stay equal. So because I multiplied this side by 2/1, I must also multiply this side of my equation by 2/1.
Oh, so you multiplied the 2 and the 6.
So I multiplied the 2 and the 6. Because this one is now down to just x. On the other side, I now have 6 times 2, that's 12. 1 times 1 is 1. 12 divided by 1 is 12. That's why we simplify. I'm glad we had that opportunity to walk back through it. Thank you. Okay. Oops. Oh, whoa. That was fun. Yeah, right. Okay, our next one. This one, relatively easy. I'm going to rewrite it just so I've got room. I'm going to try to rewrite it. 2/3 x equals 4. Our steps, guys, don't change. Regardless if you're add, subtract, multiplying, or dividing, your steps are the same. I'm going to circle my variable. I'm going to draw that line to make sure I can focus in. What number is with my variable? What operation is it?
Multiplication.
Multiplication. So the opposite of multiplying by 2/3 is dividing by 2/3. But I don't divide fractions. Instead, I multiply by its inverse. Is everybody okay with that? Because that is a huge piece for today. As long as you're okay with that and understand why, we could just do it. So instead of dividing by 2/3, I'm going to multiply by its inverse, 3/2. But anything I do to one side of my equation, I must do to the other. I look for reductions. I have a 3 on top and bottom. Those will both reduce out and become 1s. As you can see on the video, I've done it 8 times. My board's just not cooperating. So those are all now 1s. I now have 1 times x. 1 times x equals what?
1. Oh,
X. Multiplicative identity property of 1. I can multiply any number by 1. It's just that number. On the other side, I now have a whole number times a fraction, so I put the whole number over 1. I still look for reductions. Anything I can reduce? Okay. 4 and 2, I can divide both those by 2. That becomes a 1. That becomes a 2. 2 times 3 is 6. 1 times 1 is 1. 6 divided by 1 is 6. I can always check my answer to be sure I did it correctly. 2/3 times 6 equals 4. This now becomes a fraction. I have a 1 and a 2. 2 times 2 is 4. 4 over 1 is 4. 4 equals 4. Check. We did it correctly. Lillian? I'm sorry? Oh, yay. Yes, that is very good. Okay, our next one. On the scale, we're going to solve x over 2 equals 10. So here's our equal sign. On the scale, I now have x. My box x is again divided into 2. On the other side, I have 10. Eventually, I'll get to 10. So if half of my box was 10, what's in the other half of the box, Jackson? Half of my box was 10. What's in the other half of my box? Does that make sense to you? Can you see it? This half of the box, I have 10, right? So the other half of the box, I still have 10. Can everybody see that? So that means that the whole x equals 20. What does that look like algebraically? X over 2 equals 10. Here's my variable. If I have a line between my variable and my number, what operation is that?
Division.
Division.
Oh yeah, because you have the line you can use.
What's the opposite of dividing? Multiplying. So I'm going to multiply by 2 because that's my number. Anything I do to one side, I must do to the other. I now have a 2 on top and bottom. I can divide both those by 2. They cross out, become 1s. 1 times x equals x, multiplicative identity property of 1. 1 times any number is that number. 10, I put that over 1. 10 times 2 is 20. 1 times 1 is 1. 20 over 1 simplifies to. So algebraically, that's how we solve that. Does that make sense? Yeah? Because this is now a fraction, right? So to multiply a whole number by a fraction, what do I need to do? Put it over 1 to turn it into a fraction as well. Good question. Okay, now we're going to look. What if I instead I did 1/2 x equals 10? Is that going to look different? Why? Is it? Let's look. So 1/2 x equals 10. Here's my variable. There's my line. What number is with the variable?
1/2.
What's the operation? So the opposite of multiplying is division, but I don't divide by fractions, I multiply by the inverse. So I multiply by the inverse, multiply by the inverse. Look at this, our reductions, the 2's go away, those become 1's. 1 times x equals x, multiplicative identity property of 1. 10, I have to put over a whole number. 10 times 2 is 20, 1 times 1 is 1. X equals, what? Wait a minute, what just happened?
That's the same. Look, Mr. Marcel, look.
Did I make a mistake?
No, Mr. Mark.
No way, man, you guys are starting to know me too well.
Yay!
So how did I get the same answer?
Because you hacked the game.
Gabby?
Because the 2 over 1 went, okay, so you multiplied the 2 over 1 with that,
Right,
and then you multiplied the 2 over 1 with that,
okay.
and then...
So why did I do the same thing?
No, because the numbers are the same.
I have an idea.
Because
Do that
what does
because-
dividing by 2 mean? It's the same as multiplying by 1/2. I just proved it. Here I divided by 2. Here I multiplied by 1/2. Guess what, guys? That's the same thing.
Mr. Moore, I have a question.
Multiplying by 2, or dividing by 2 is the same thing as multiplying by 1/2.
But Mr. Moore, I have
20. It's the same thing.
But Mr. Moore,
Again, I asked you if I was wrong.
Mr. Moore, Mr. Moore,
Yes, Jaden.
then why would you have the well,
Guys, please be quiet.
why would you have the
KO. Jaden, please finish your question.
why would you have the 1 if the x is there for the fourth one?
For the first one, because this is a fraction, right? What's the opposite of dividing by 2?
Multiplying.
Multiplying by 2. But now, I have a whole number times a fraction. How do I take a whole number times a fraction?
Oh, now I get it.
I put it over 1 to make it a fraction as well.
Okay, I get it.
Make sense? Okay. So, the bottom line, guys, here's your work. We're going to finish this in class. I will do our first one for us just to make sure you understand. Here are your steps. Step 1, circle my variable. Step 2, draw a line through the equal sign. Step 3, find the number with my variable. What number's with the x? Okay. 11, what's the operation when I write them side by side? Multiplication. So the opposite would be divide. So I divide by 11 to both sides. Anything I do to one side, I must do to the other. 11 divided by 11, those reduce away and become 1. 1 times x is just x, multiplicative identity property of 1. 55 divided by 11 is
5. Easy math.
Quick math.
easy. Okay, I will let you work together as a table. We've got, I'll give you guys 6 minutes to do those 5 problems. Okay, guys, we got 4 minutes left, so I'm going to have to fly. Pay attention.
Do that?
I can. The opposite of dividing by 7 is multiplying by 7. 7 over 1, those become 1s. I have r equals 35. Our second one, here's my variable. The opposite of dividing by 8 is multiplying by 8. Those go away, become 1s. I have j equals 48. On this one, here's my variable. The opposite of multiplying by 35 is dividing by 35. Those go away, become 1s. I just have q. 5 divided by 35, here's where step 5 comes in. I can actually divide both those by 5. That gives me 1/7. Here's my variable. Instead of multiplying by 5/6, I multiply by the inverse, 6/5. Those all go away, become 1s. I multiply this side by 6/5 because I have to do the same thing to both sides. My 6 cross out. I have 1 over 5. 1 times k is just k equals 1/5. The one that probably caused the most issue, slam dunk, guys. I should have circled that. Circle my variable. The opposite, this one is actually 5/3. 3 times 1 plus 2. The opposite of multiplying by 5/3 is multiplying by its reciprocal, 3/5. So I multiply both sides by 3/5. Quick heads up warning. Most common mistake on the quiz. You turn it to an improper fraction, you forget to do its opposite because you've already done some work. Don't forget that. So now I just have j. This one goes over 1. I have a reduction there. I can divide both those by 5. 3 times 3 is 9. Here's why I rushed through that, because we need to get to the homework. I need everybody on top of your paper to write no work equals no credit.
0%.
0. That is an absolute 0. I'm not being nice and giving you half credit. If you don't do it, you get 0. Why? I left you easy numbers. Because I left you easy numbers, now I will warn you, it's all 4 operations. That was intentional. So the process is the same. There's my variable. The opposite of adding 5 is subtracting 5. Those go away. X equals 7. As you've done with multiple of these puzzles, what that means is everywhere down at the bottom that I see the number 7, I write in the letter D. When you get done, you'll have a message. If you did not write the no work equals no credit, I might just not give you credit anyway. And I have it on video to prove that you were warned. So this is even doubly a bonus. Any questions?
Wait, what you do for D? No, it's right.
Seriously? Instead of adding 5, I subtracted 5. Okay, guys. That is your lesson for today. Good luck.